In this video, we're going to look at one explanation for price dispersion. In the picture here, we have prices for the Xbox One S console on the Amazon website. And in the image, you can see that there are various prices being charged. The lowest price here is about £210. And then there are the prices here which are very similar. But at the bottom here, we have some prices which are very different. So this highest price here is £50 more than the lowest price. So roughly we have here two groups of prices. We have some low prices and we have some high prices. So the prices here are different, but they're all for the same product. So how can we explain that? In the Bertrand model, all firms priced at marginal cost. And in the search model, all firms priced at the monopoly price. So in neither of those models where the product was homogeneous did we have price dispersion. However, we often observe price dispersion, different prices being charged for exactly the same product. So how can we explain that? One explanation here is that consumers have different costs of search. So the idea here is that consumers with low or zero search costs find out all the prices and therefore buy from the firm with the lowest price. So those consumers would be the ones buying the lower priced consoles. Whereas consumers with high search cost do not search and choose a firm randomly. So consumers with a high search cost could end up either buying at the low price or the high price. What this means is that firms pricing high and pricing low can both make sales. The low price firms sell to both types of consumers, those with high search costs and those with low search costs. Whereas the high price firms sell only to consumers with high search costs, and so they're going to be selling less than the low price firms. Now this can be in equilibrium as long as both types of firms are making the same profit. And in our model, we're going to assume that there's free entry and exit into the market, so we need both types of firms to be making zero profit. This can only be true if the average cost is not constant. So in our model, we'll assume that the average cost curve is U-shaped. And so the average cost of the high price firms can be higher than the average cost of the low price firms because they're selling different quantities. So the model we're going to go through is called the tourists and natives model. You can find this in the Carlton and Perloff reading, which is available online through the reading list. In this model, there are a large number of potential entrants into an industry with identical U-shaped average cost curves. And in the model, the equilibrium number of firms is determined by free entry. So this means that each firm must be making zero profit in equilibrium. Otherwise, if they were making negative profit, firms would exit. If they're making positive profit, firms would enter. So in the diagram here, we have our quantity Q, we have our average cost curve, which is U-shaped. And here I've marked off two values. So V is the monopoly price. It's the most anyone is willing to pay for the good. And PC is the minimum of average cost. I'm going to mark off two quantities which will be important. The first quantity is the competitive quantity, QC. It's the quantity that minimizes average cost. And the other quantity is the quantity QV, which is the smaller quantity where the average cost is equal to V. So we've described the cost function of the firm. What about the consumers? Well, there are L consumers, each consumer willing to pay up to V for the good. A fraction alpha are natives, that is, a fraction alpha are informed consumers. They have zero search costs, they know all the prices. So there are in total alpha L natives. A fraction 1 minus alpha are tourists. These are uninformed consumers. They have very large search costs. They choose a store at random. There are 1 minus alpha L tourists. So the informed consumers know the lowest price being charged, so they visit and purchase from a store with the lowest price. So firms charging the lowest price get an equal share of the informed consumers, they get an equal share of the natives. Uninformed consumers don't know the prices, they choose a store at random. Every store gets an equal share of the uninformed consumers. So uninformed consumers go to both high price stores and lower price stores. So we'll start by looking at two extremes. So first we're going to look at the case where alpha equals 0. This is the case where all the consumers are uninformed, all the consumers are tourists. So this is just going to be like the search model, except there's no search. So there's going to be imperfect information here about prices. No one's going to know the price that any particular store is charging. So with alpha equals 0, all consumers are going to choose a store at random. So the equilibrium in this model when consumers are uninformed is that all the firms are going to price at V, and the equilibrium number of firms is going to be L over QV. This just comes from the zero profit condition. The zero profit condition is that Q of V is equal to L over N. That is, each of the N firms' share of the L consumers is equal to the quantity where average cost is equal to V. So we need to check that this is an equilibrium. In the proposed equilibrium, each active firm is selling QV units and making zero profit. If an active firm raises their price, what happens? Well, in the picture, I've drawn the demand curve of a firm given that all the other active firms are charging a price of V. If this firm charges a price more than V, it gets no demand because consumers are only willing to pay up to V. If it prices less than V, then it doesn't increase its demand because consumers don't know that its price is lower than the other firms. So if an active firm raises their price, their demand will be 0, so they're not any better off than they were by pricing at V. If an active firm lowers their price, their demand is also going to be unchanged because consumers do not observe the price cut. And so actually they're going to make a negative profit because they'll be pricing below average cost. There is no incentive for another firm to enter because they would make a negative profit. N would go up and the quantity each firm would produce would go to the left, and firms would now be producing less than QV and the average cost would be more than V. There is no incentive for a firm to exit because a firm that exits makes zero profit, which is the same as what they're making by being active and producing QV. So it's an equilibrium when no one knows the prices for all the firms in the market to price at V and sell QV units each. Now we'll look at the other extreme where alpha equals 1. All the consumers are natives, all the consumers know the prices. In this case, all consumers will visit the lowest price stores, just like in the standard Bertrand model. The only difference here is that the average cost is U-shaped. The equilibrium when alpha equals 1 is that all firms price at PC, the minimum of average cost, and the equilibrium number of firms is L over QC. Again, this just comes from the zero profit condition. Each of the N firms is producing QC units, and in total, the firms are producing L. So again, we need to check that there's no incentive to deviate. So in this proposed equilibrium, each active firm is selling QC units and making zero profit. On the diagram, I've drawn the demand curve of a firm given the other firms charge PC. So let's think about a deviation by this firm. If this firm raises their price, then they're going to be pricing above PC, above all the other firms. Because all the consumers are natives, they observe that this firm's price is above all the other firms. This firm will get no demand. Their profit will still be 0. They're no better off than pricing at PC. If this firm lowers their price, they'll get all the consumers. They'll be the lowest price firm, but their price is going to be below average cost because it's below PC, the minimum of average cost. So this firm would make negative profit. They're better off pricing at PC. And again, there's no incentive for another firm to enter or to exit. So we have these two extremes. When alpha equals 0, it's just like in the search cost model, firms price at the monopoly level. Whereas when alpha equals 1, everyone knows the prices. It's just like in the standard Bertrand model, they price at the competitive level, the minimum of average cost. Now we're going to look at intermediate cases where there are some of both types of consumer. There are some tourists, there are some natives. Before we do that, we need to introduce some notation. Beta is the fraction of firms that charge the lowest price. So they are the fraction of firms that will sell to the natives. When there are n active firms, there are going to be beta n firms with the lowest price, and they're going to get an equal share 1 over beta n of the informed consumers. All of the n firms are going to get an equal share 1 over n of the uninformed consumers. Now we'll start by looking at the case where there is a single price equilibrium. So we're looking at the case where alpha is sufficiently large. So the idea here is if there are not many tourists, then the average cost from selling just to the tourists will be more than the monopoly price. And so it won't be worthwhile to deviate to a high price. So if there are a sufficiently large number of informed consumers, alpha is large enough, then the equilibrium is for all firms to price at the competitive level. The equilibrium number of firms is L over QC. So this is just the zero profit condition again. In the proposed equilibrium, each of the active firms is selling QC units and making zero profit. In the diagram here, the red line is the demand of a firm if the other firms charge PC. So we're looking at the demand of a firm that might potentially deviate from this proposed equilibrium. In the proposed equilibrium, each firm is producing QC, making zero profit. So a firm pricing at PC is selling to both tourists and natives. So the tourists, the uninformed consumers, are here, and the natives are here. If this firm raises its price from PC, then it will no longer sell to the natives, it will only sell to the tourists. And if it's going to raise its price above PC, it may as well raise its price all the way to V, because demand will be unaffected for prices between PC and V. And at a price of V, they're actually going to be making a negative profit per unit because the average cost is more than the price. So because alpha is relatively large, the number of tourists they sell to is going to be quite small, and therefore the average cost will be quite high and above the monopoly price. The rest of the argument is the same as for alpha equals 1. So we saw that if alpha were large enough, then it was still in equilibrium to price at the minimum of average cost, like in the Bertrand model. But if alpha is small enough, then it's no longer going to be an equilibrium. The idea is if there are enough tourists, enough uninformed consumers, then the average cost from selling just to the tourists will be less than the monopoly price. So whereas before we showed there was no incentive to deviate from the competitive price PC to the monopoly price V, now there is going to be an incentive to deviate from PC to V when all the other firms are charging PC. What we'll show is that if there are a sufficiently small number of informed consumers, alpha is small enough, then it is not an equilibrium for all firms to charge the competitive price, and it is not an equilibrium for all firms to price at the monopoly level V. It is also not an equilibrium for all the firms to charge any other single price. So let's start by showing that it is not an equilibrium to price at PC. So just as before, we've drawn the demand of a potentially deviating firm. So here we have the same picture as when alpha was equal to 1, except this line here has moved to the right. Alpha has got smaller. So when all the firms price at PC, they get an equal share of all the consumers, and the quantity here, QC, is what they produce. They're making a zero profit. If a firm deviates, then they get only the share of the uninformed, the tourists. And because alpha is now smaller than it was before, 1 minus alpha is larger, the share of tourists is larger than it was, this line is shifted to the right. Now the point here, when the firm is pricing at V, the quantity demanded is above average cost. So they're making a positive profit per unit if they deviate to a higher price equal to V. So this is the difference to the case where alpha was larger. Now the firm can make a positive profit by deviating and selling at V to just the tourists. Why is it not an equilibrium for the firms to price at V? Well, if each of the firms are pricing at V and selling QV units, the quantity where the monopoly price is equal to average cost, well, they're going to be making zero profit. But if a firm were to deviate and lower its price slightly below V, then they're going to get the informed consumers, and this is going to reduce their average cost below V. Finally, we're going to look at the case that is most interesting. We'll look at the case where there is price dispersion. So we'll show that if alpha is small enough, there's a two-price equilibrium. So when there are enough informed consumers, then it is an equilibrium for some firms to price at the competitive level and some firms to price at the monopoly level. The equilibrium number of firms will be this quantity here, and the equilibrium fraction of low price firms will be this quantity here. You can see where those numbers come from in the footnote and also in the reading, but they're not that important for what we're doing. You don't need to know how to get them or remember them. So in the proposed equilibrium, each active low price firm is selling QC units and makes zero profit, while each active high price firm is selling QV units and making zero profit. So both types of firms are making zero profit in this proposed equilibrium. So to show this is an equilibrium, we need to show that low price firms don't want to deviate, high price firms don't want to deviate, and there is no incentive for firms to exit or enter. So let's start by explaining the diagram. In the diagram, the red line is the demand curve of a firm that's potentially deviating from pricing at PC. So let's consider a low price firm. If they raise their price, then they're going to want to raise it to V, and the most they can make is zero profit. If they raise it to V, then they're going to sell only to the tourists, they're going to sell QV, and they're going to make zero profit. If they raise the price above V, then they also make zero profit. If a low price firm lowers its price, then their price is going to be below PC, and they're going to be making a negative profit. If a high price firm raises its price, then its price is going to be above V, they're going to make zero profit. If a high price firm lowers its price enough to increase demand, then its price must be PC. It's going to be making actually a negative profit because now there are more low priced stores. They're going to each be selling less than QC. They'll be over here somewhere making a negative profit. There is no incentive for a firm to exit or enter because a firm that exits makes zero profit, the same as they'd make in the market. Whereas if a firm enters, then they're going to make negative profit because they will be producing a lower quantity than QC or QV and the price will be less than average cost. So to summarize, when alpha is sufficiently small, there is a two-price equilibrium where some stores are pricing at V and some stores are pricing at PC. Both types of stores are making the same zero profit. So we've shown that the type of equilibrium depends on the size of alpha, the proportion of informed consumers. When alpha equals zero, we get monopoly pricing. So this diagram shows the average price in the market. When alpha is zero, the average price is the monopoly price. With a large fraction of informed consumers, we get competitive pricing. So in this range here, we get competitive pricing. Whereas in the intermediate range of alpha, so above zero, but less than this quantity here, we get two prices. We get some firms charging PC and some firms charging V, and therefore the average price is somewhere in between. In the diagrams above, so in the middle diagram here we have beta, the fraction of low price firms. So when alpha is sufficiently large, there are enough informed consumers, all of the stores are low price stores, beta equals 1. When alpha is small enough, there are enough tourists, there are both types of stores, and beta is somewhere between 0 and 1. Whereas when alpha equals 0, every store is a high price store, beta equals 0. And what happens to the number of stores as alpha changes? Well, in this range here, where all the stores are low price stores, the number of stores is constant at the value where producing QC units makes 0 profit. When alpha is less than that quantity, then there are both types of stores. The total number of stores is decreasing in the proportion of informed consumers because the low price stores sell more. It takes fewer stores to sell to the L consumers as the proportion of low price stores increases. So that is why N is fallen. So the red line here is the number of low price stores. It increases with alpha, and the number of high price stores decreases with alpha. So this is just one explanation for why we might get price dispersion. The idea is that we have two different types of consumers with different search costs, and because of the U-shaped average cost, we can have two different types of stores, some stores selling at a low price to both types of consumers, some selling at a high price to only the uninformed consumers, and both types of firms are making 0 profit. There are other explanations. In some of the models, we have constant marginal cost, just like in the Bertrand model, so it's not necessary to have a U-shaped average cost to get equilibria with more than one price. There are models also where there aren't just a finite number of prices. Any price in between marginal cost and the monopoly price can be charged by a firm. There are models also where firms have a mixed strategy and they're randomizing between different prices. Other explanations of price dispersion relate to differences in costs, differences in the products the firms are producing or the services they offer, so product differentiation and differences in costs, and other differences between firms can explain price dispersion. Here we were looking for an explanation that explained price dispersion when the products were identical and firms had identical cost curves.